Hi, everybody. This is Mark Nelson from Oracle, and Peter Nagy is with me. I'm actually from Australia, not America. I had the wrong flag on my picture. And I apologize, I can't speak Spanish, but please tell me if I'm not loud enough or too fast, or if you need me to change. So we're going to talk about Go microservices and Java microservices, and whether whether Java microservices can run as fast as Go. Yeah, you want to go to the next one? That's me and Peter. You want to show? Here's Peter. Okay, so
okay, sorry.
wrong slides.
we had some mistake because we had some description and I don't know where it is. Okay, so never mind. So if you could give some short introduction about you, what is your role at Oracle or stuff like that, please?
I think you've got, does this got the premise slide? Is this like the wrong slides altogether? You want to check? I'll just talk. So I'm in the enterprise cloud Java team. So I work on things like Kubernetes, Istio, enterprise container platforms, and for Java EE and Java microservices. Peter, also same team. So I was also in the A team for a while, so I did lots of work on performance tuning and that sort of stuff. And I program mainly in Java, Python, and Go these days for work, and then other languages for fun. Yeah, if you want to go on. Peter is in the same team. Peter is one of our product managers, and he travels around the world teaching people about how to use the various technologies and doing hands-on labs. He wrote some of our most popular tutorials, and he has written a tutorial about using Helidon to write microservices and to migrate from Java EE applications into microservices and so on. So it's a little bit about us. So the premise, or what we wanted to do for this session, was, I think there's a common belief in the industry that maybe Java is a bit old and it's a bit slow and boring, and Go is like new and really fast. And we were wondering, is that really true? So we thought we would set out to create some microservices in Go, and then re-implement the same things in Java. Excuse me, and do some tests to see if we could, work out if Java can run as fast as Go. So we're using a very simple microservice. It doesn't have any external dependencies like databases or load balancers or anything like that. We're basically just manipulating strings. So that way we know that they're pretty close in the implementation. But we did include things like metrics and logging, because those are almost always included when people write microservices. We used very small, lightweight frameworks. So we used Helidon for the Java implementation, and we used GoKit for the Go implementation. And we did also experiment with just using pure JAX-RS without a framework in Java. We used several different versions of Java, different JVMs. We changed the heap size and garbage collection and so on. And we also tested the microservices with and without warming them up before the test runs. So next one, please.
Okay, this would be my part, thanks. Sorry for the glitch. Okay, so a couple of things about Java. I think I shouldn't say too much about Java, because Java has been here with us a very long time. So the first release was available in 1996, as you can see on the slide. And I can only gather information from Google Trends till back 2004 only, so we don't have more data, but obviously there were no Go at that time. So there you can see on the right part of the slide the Google trend comparison. So if we if we measure the Java popularity in 2004, like 100 unit, so you still can't see or barely see the Go popularity at this moment. So Java is still the most popular language, and even if you check other statistics like top languages, so still Java is one of the most popular languages, even if we have new things like JavaScript also on the server side as well. But if you look at our most favorite web page when we develop application, the Stack Overflow survey result, or also the statistics on Stack Overflow, still Java has almost the most topics on Stack Overflow, and compared to Go, it's far more topics available there. Okay, what we have now, so we have this language very long time, and the main design goals originally at that time, maybe there are a couple of participants who are relatively young compared to me, and I need to explain what was the reason of the popularity of JVM, the Java language at that time. So the main design goals for Java was the portability, because at that time it was pretty chaotic, and this was the first language which really ensured the portability between operating system and infrastructures. So you need just to create the source code which can compile to a bytecode, and then you can run that bytecode wherever there's a JVM implementation on top of the operating system. The other good thing in Java is the memory management, especially also in that time. Nowadays, most of the languages has garbage collector mechanism, so you don't need to really work hard with the memory allocation and freeing up the memories. But at that time, it was the first language which had this beautiful memory management. So you don't need to care about how to allocate memory for your objects in the applications, and you don't need to care about how to freeing up those area. Okay. So that makes really easy to use this language and made it really productive. Okay, so as I thought, still one of the most popular languages, and due to this reason that it is pretty old, there are tons of Java developers out there. There are tons of Java applications out there. So definitely Java is still evolving and changing in a good direction. So we shouldn't consider as Java is dead. Okay, so what is the problem with Java, what Mark also mentioned? So these areas mainly about the memory usage, the garbage collector, because that makes hard this runtime as a real-time runtime environment. And so one of the biggest problem with the memory usage, as I told you, that Java is an interpreted language. So Java has a two-step compilation process. So first you are going to create a bytecode from the Java code, and this is executed by the JVM. But this is still not, the bytecode is not a native executable instruction set. Okay, so this is what needs to be interpreted for the operating system by the JVM. Okay. There are a lot of things around the JVM which requires memory. So even if you can tune your heap to be really small, like in our case in this test, we only need something like less than 30 megabytes of heap, it still has a really huge memory requirements, just to feed the JVM stuff itself. Okay. The other stuff, the garbage collector also evolved during the years. So you can choose what kind of garbage collector do you want to use. It depends on the characteristics of your application, but usually nowadays you are using the latest one, the G1, which promises the most efficient garbage collection. So what it does, as I mentioned, it freeing up the memories. So whenever an object is not needed anymore, it will free up that area, and you don't need to care about how to allocate memory. And definitely it requires some amount of CPU and time, and this makes really critical from real-time perspective, the JVM language. Okay. Another interesting part of the JVM, the JIT, the just-in-time compiler, which is really interesting, and you will see this is why we need sometimes warm up the engine, because when the JVM execute the bytecode, then over time it will collect statistics about the code usage, and the most hot and most popular code parts will be optimized and translated directly into a native instruction set, which can be understood by the hardware CPU and on the fly at runtime, okay? Which makes really fast, in this case, the Java application also, okay? What's new here is that maybe you're already aware about GraalVM. GraalVM has a new compiler written in Java, and that allows much efficient compilation and optimization of the bytecode, which is translated directly into a native executable instruction set. And that makes really fast the Java whenever it has started and warmed up, I can say. Okay, a couple of facts about Go, and I take over to Mark.
Yeah, so Go was created by Robert Griesmer, Rob Pike, and Ken Thompson, who are all at Google at the moment, or when Go was created. So you may recognize those names. Ken Thompson, for example, was one of the original creators of Unix. He created the B programming language, which was the precursor to the C programming language. He wrote the first windowing system for Unix, and so on. So these are guys who've been around Unix and C and that style of development for a very long time. It's an open source language. It's having very, very rapid growth. The 1.0 release was in 2012, and I think they have actually released 1.15 in the last week or two. So they're rapidly putting out new releases. It's heavily influenced by C and also other languages like Python and JavaScript. As you can see, there's a much smaller number of questions compared to Go, but it's compared to Java, but it's rapidly growing. The next one, please. So it's a statically typed and compiled language, which means it's compiled into a native executable. There's no interpreter or virtual machine in the middle. The syntax is like C, but it does have memory safety and garbage collection. It uses structural typing, not an object-oriented language. And it does have communicating sequential process concurrency. That's implemented with lightweight processes that are called Go routines. And those are not run as operating system threads. They're much more lightweight than a thread. Excuse me. And it uses a mechanism called a channel for communication between these parallel execution paths. It does not prevent race conditions. You still have to do that yourself. And it was designed to have very high performance, primarily for networking and multiprocessing applications. So it's used by many popular projects. So you would have heard of things like Kubernetes and Istio and Prometheus, for example. Those are all written in Go. And most of the things in the whole Kubernetes cloud native ecosystem are written in Go. It's designed to have very fast build time and to execute very fast, and it's fairly opinionated. So, for example, they dictate the format of the code. You don't get to choose. So all of those arguments that people have been having about, whether to put the braces on the same line or the next line, or whether to have 2 spaces or 4 spaces indents, none of that applies in Go because they just dictate the format. Next one, please. So what are some things that are good about it compared to Go, compared to Java? This is from my personal experience. It's a lot easier to implement functional patterns like pure functions and composition and immutable state. There is much less boilerplate code than you have to write in Java, but still too much in my opinion. It is still very early in its life cycle, so they don't really have to worry quite so much about backwards compatibility as Java does, and they do break things quite often, which can be a challenge. It compiles into a native statically linked binary, which means that that binary has everything that you need to run the program inside it. Which means, for example, you could put that in a container, what's called a from scratch container, which has nothing else, like no operating system libraries, nothing at all, just literally that one binary. And that container will be like really, really small and fast to start up and execute quickly and so on. It does not have, as I said, it's not object oriented. There's no objects, there's no inheritance. There are no generics, although they're talking about adding generics. There's no assertions. It doesn't have pointer arithmetic, which was also a lot of problems in C. They have a lot less use of parentheses. For example, like in an if statement, you don't put the condition in parentheses. It enforces that you cannot have cyclic dependencies. It will not, the compiler does this, it will not let you have code with an unused variable or an import statement that you don't use. It'll refuse to compile. And it won't let you do an implicit type conversion. So the next one, what are some negatives with Go? Again, this is from my experience and compared to Java. So the big one, excuse me, the big one for me is the tools ecosystem is really immature compared to Java, especially for dependency management. So there used to be a lot of options and people used different ones, and there was not really a clear winner. But now there is one which is called Go modules, but still a lot of people haven't adopted it. It forces a certain versioning scheme. It works really well for open source things, but if you have like private repositories, it gets to be quite challenging. So still lots of problems there. Building code with new dependencies is really, really, really slow. And the way they do imports actually ties it to the repository. So if you need to move code around, it gets to be like it's like a nightmare. It's very difficult. The IDEs are good for like programming and looking up documentation and autocomplete, but things like debugging and profiling and that are still a little bit hard. And you have to use pointers again. I thought, I would never have to use pointers again after I left university 20 years ago, but here we are. Next slide, please. There's no exception handling like in Java. You have try catch. There's no such thing in Go. You basically you end up very often writing error equals do something. If error is not nil, then whatever. And they typically will like panic if there's a problem and just crash. So it's kind of a lot more low level. There are no functional primitives, like there are no lists, there's no map function, there's nothing like that. So quite often you'll end up writing stuff like, you find yourself writing things that you haven't written since you were in university learning about algorithms and stuff. Like recently I had to write code that literally like walked through two lists, item by item and comparing them and transforming them and so on. Whereas in a functional language, like in JavaScript or Haskell or something, I could have just used a built-in, but I had to like go and re-implement that algorithm myself because it doesn't exist in Go. There is no dynamic linking, so you can't use a dynamic link library, which might not sound like a big deal, but depending on what you're doing, like if you're writing code that's not open source, so you're writing code within your company and you want to use a library that uses GPL, then if you statically link it, it makes your code GPL as well, which can be undesirable. And so, it can make it hard to use some dependencies. And, Peter was talking about the garbage collection. Java's garbage collector has like hundreds of options to tune it and make it, perform in different ways. Go only has one option. You can have it on or you can have it off.
Okay, so a couple of words about our test scenario. So again, we wanted to test really a simple REST endpoint invocation. So without any database backend, which makes, involve other latency or other stuff. So We have implemented this, as Mark mentioned, using Golang and also Java Helidon. We also considered that to implement the endpoint using the pure JAX-RS, but we realized that the Helidon implementation was much faster. So we decided to go with the Helidon one. For the tool, we are using JMeter. I think that is pretty popular for load testing. And again, so this is just a basic string manipulation. It's uppercase or counting the characters of the string. Okay, so nothing else basically. And also, Mark mentioned that we had a lot of options to tune the garbage collector and stuff like that. But at the end of the day, we saw that even if we really want to tune the garbage collector, it doesn't matter for such small business logic, I would say. Okay, so finally we decided, okay, the first what we are going to measure, out of the box Go, and out of the box the Java. Okay, and if necessary, then we are going to start to somehow tune. But as I told you, we started, but there were no really huge difference between the results in this case. Okay, the test environment. First, as a reference, we did a run on a desktop, which is basically my desktop. By the way, the source is available on the GitHub. Sooner or later, it will have more documentation, but you can find the codes, the scripts to run. So what you need is only a JVM, Golang, and JMeter. And once it has set, then you are good to go and run all the tests, what we are showing. Okay, so the first one is on my desktop, which is a pretty slow computer, but this can be good as a reference point. And this also, you will see immediately, it also shows some interesting results as well. The second one is on a cloud. So first we are running our application on a compute instance, which has much more resources compared to my desktop. And also, obviously, since we are talking about microservices application, we wanted to test on Kubernetes cluster as well. So what we measure, basically the main thing what we measure is the throughput, but also the response time is interesting. So we are going to show the response time as well. But obviously, what we would like to check is the throughput. It was hard to agree how we measure the memory, especially in case of Java, because as I told you, the JVM itself requires a lot of memory. However, we need to consider this fact whenever we develop microservices application, especially we are deploying on Kubernetes, so we wanted to include as well. But basically we agreed that the memory, what we are tracking for the real usage, so which is used by the application, the object itself during the load, is the resident set size area, which is basically the portion of the memory occupied by a process that is held in the main memory. So we can consider that as an active memory part, so not swapped out or nothing, not on the file system or stuff like that. Okay, so let's see the first result here. Okay, so this is the slowest one. The test scenario is basically almost the same. No, it is the same in every scenario. We will have 100 thread, which is basically 100 user, and we will have 10,000 loop per thread, just to invoking the REST endpoint, and we are giving 10 sec ramp up time, so not too much. Okay, we are using GraalVM, but for Java it is like a simple JVM, so nothing special for GraalVM. And we are using Helidon 2.0 and Golang 1.13.3. So let's see the first result on my notebook. I forget to write, but I need to, and I will do it later before sending slides. In this case, the CPU usage was almost 100% in my case, because as you can see, this is a pretty old one, MacBook, which is a dual core i7 with only 16 gigabyte RAM. Okay, so what you can see as a result, okay, we started the logging, which gives a fairly amount of work for the CPU. Okay, so first with logging, then without logging, then we do some warm up, which shouldn't be interesting for Golang, but it seems based on the measurement, it really matters. But really few. Okay, so we can think of it. It is really necessary, but this is mainly about my environment. I try to switch off every other background processes and programs on my laptop during for the test. But what you can see in case of the Java, that when we have the logging and we don't have warmup, that is a really huge performance penalty for Java. And also, if you can see the memory consumption, there you can see that Golang has much fewer memory requirements. So comparing to the 50 megabyte to the total reserved 1.5 gigabyte. Okay, but the residential set size is much lower, and also if you can see the incrementation of after the load. So we had measured the memory at the beginning, at the and at the end of the test as well. So the increment is not too much, but compared to Golang is still much. But compared to the base size of the JVM requirements. Okay, so what you can see here is basically JVM needs a warm-up because of the JIT. Okay, so without a warm-up, you will get pretty bad numbers. But if you have the warm-up, you are getting closer to the Golang. Okay, so this is the first round result. As I told you, the log is a nightmare, kind of nightmare. But we need to consider the fact that usually if we are running a microservices application in the cloud, so for example, Kubernetes, we are not going to write logs in the container. So maybe we are using log system, and also we are not printing out info level logging. So this log here means info level log, and whenever you switch to another level, for example warning, you are not going to see any unnecessary log entry. Okay. As I told you, the memory is really critical for the JVM, and also the warm-up. But if we stop for a moment, as we thought how Go works and how JVM works, so we are comparing two different execution models here. So Golang is compiled into a native executable binary, while JVM has an intermediate mechanism, I can say. Okay, so at this point, we decided we will include GraalVM native image, which can make much more equal this test. And also still you can use your Java skills, because you can write the Java code with your favorite Java IDE, Java tools. And when you have the code is ready, then you can compile using GraalVM native image into a native executable binary. How it happens, Mark will tell some word about this.
Yeah, so as Peter said before, GraalVM is Oracle's new virtual machine for Java. It's actually a polyglot VM, so it supports other languages as well, like Python, JavaScript, R, and even LLVM languages like C. So it has a feature called native image, which allows you to do ahead of time compilation of Java code to create a standalone statically linked executable, just like before when we were talking about Go. So it kind of gives you the equivalent. It lets you take a Java program and compile it down into native code that contains like the application classes, classes from any of the dependencies that it uses, runtime library classes from the JDK, and so on. And it's all statically linked. So it does not run on the Java VM. It runs as a native binary. It still has a very, very small VM that we call the substrate VM, which just provides things like optimization, garbage collection, thread scheduling, and so on. But so this brings us like a much closer to the Go execution model. Back to you, Peter.
Yeah, so basically, again, the goal is we have Java developers, and we need to decide whether we want to go with Go, or we will stay on Java and writing Java microservices, which fits really in this containerized microservices world. And using native image, you have the option to still use Java, but at the end of the day, you will get a natively executable binary. So let's include the test, the GraalVM native image as well. Again, my notebook. So let's see again the runs. There you can see Golang is still the winner but native image is much more closer, can be closer to the throughput as well. So if we are not considering the warm-up time as well, but this is still not enough close. The JVM is still better, okay? But this is again, you will see in the results soon that this is because of my environment. Because as I told you, when I run the application on my desktop, it consumes all the CPU. Okay, so I think this is not a fair measurement at this point. So we decided to move to some bigger environment. Before that, let's see just the response time graphs. And this is what you can accept basically from JVM. So if you can see the JVM ones at the bottom of the slide, there you can see, so for example, with no warm-up on the right column at the bottom of the slide, there you can see there's a peak 200 millisecond at the beginning, which is because of the JIT compiler. So the JVM just started and start to interpret the code, and later it will, yeah, thank you. And later it will compile the necessary bytecode into a native instruction set. And after that, still we have some optimization, but there you can see at the end of the run, it's pretty smooth. Okay, I can't really talk much about the Go execution model, but you can see also there is also some kind of peak at the beginning. Okay, so every language has some optimization. This is what you can see, but what is much more higher in case of the Java, the traditional Java approach. And there you can see the native image, which is also a kind of pretty flat execution with a couple of peaks as well. Okay, so let's move away from my slow computer and let's have a bare metal, okay, with 36 CPU, which is basically, since it's bare metal, it's basically a processor core itself. We have 256 gigabyte RAM, so this is a huge one, and we are still keeping the same test scenario, only 100 thread. And let's see what we have at this moment. It's much more interesting. Okay, so at this moment, native image was the fastest, but if you can see the Java runs without logging, okay, I still included on this measurement only the logging, but you don't need to really care about that one. So if you see the Java runs without warm-up, that is also pretty fast, okay, even faster than the Go run, which is interesting because there is a huge difference in this case if we running in this environment. But again, this is not a traditional microservices environment. This is just a huge computer where we did the test, okay? So we have 36 CPU, okay? And we have only one instance of the JVM and Go application and native image application.
So an interesting thing here is these are dual thread CPUs, so there are 72 threads running, and we noticed the Go when we ran the Go test, it was much less efficient at using the CPU. There was much lower CPU use than Java, so it seems like Java is better at using more of the available resource. And you know, because the Java CPU usage was higher, and you can see it got more work done. It got higher throughput. It got better response time. So that was an interesting observation.
And also interesting to see the pressure of the memory requirements, even in the case of Golang. So if you remember what happened in my desktop, that was only 15 megabyte at the end of the run as well in case of Go, but now it's much higher. So as Mark told, they have much more resources. So it seems maybe Java utilize better those resources. Okay. I have a couple of response time graphs here as well. I have 3 slides. So first one is with the logging without no warm-up. But even, so there you can see, even in the case of native image run, you still can see some high peak at the beginning and also during the run as well, okay? So if you really see the Go one, you will not get really huge peak. Even the throughput is less than compared to Java. Okay, so this is where the debate, you know, starts. So if you have that peak at that time when you don't need that peak, so that can be a problem, obviously.
And those peaks are almost certainly garbage collection. And interesting to see in Go, there's really two, and with Java, there's really one big one, but the native image one down the bottom, the native one down the bottom. Notice it's doing much more smaller garbage collections all the time, by the look of it.
Okay. And yeah, a couple of other, so we don't have log at this moment, and we still don't have warmup type. This is kind of similar to the previous one, but it depends, you know, the sampling interval. I used 100 millisec sampling for all graphics, but if you are changing these sample time, then you will get bit different, much more noisy graphs as well. And this is with warmup. Okay, so whenever we have the warmup, there you can see, even in case of the Go and the Java and the native, the highest peak is under 40. Okay, so once we have the warmup and the JIT is done with the optimization and the translation, then we have the same result. Okay, and this is where native image comes in the picture. Okay, not just about, okay, we have a natively executable binary, but that can eliminate this kind of peak at the beginning. So native image doesn't require any warmup, as you can see, like Go. Okay, so let's move forward. We wanted to test on Kubernetes, since we are writing microservices application. Now we have a really good candidate in case of native image, because we still can write our favorite Java application, and at the end of the build, we are compiled into a natively executable binary. Okay, so what we did, we created Docker images, and in case when we have the option to create, we created the Docker image from scratch, and there you can see the sizes. So for example, the native app and the Go app is under 25 megabyte, the whole image itself. And the same application, without any optimization, like in case of Helidon, it requires 1.4 gigabyte, okay? As a container image. And we also included in the test the JLink version of the build of the Java application, which allows you a modularization. So it just only contains the required Java modules, which allows a much less footprint.
The image size is really interesting in Kubernetes because when you want to start a new pod and start a container, say you want to scale up, you know, start some more pods to handle increased load, the first thing it does is make a copy of the image for the new container, and it's a copy on write file system. So it's you know, it's relatively quick, but the size does make a difference. Like you could notice, you know, we didn't measure this, but I know from other work we've done, like the difference between having like an 11 megabyte Docker image and a 1.4 gigabyte Docker image, you know, it might be, you know, a quarter of a second extra that you have to wait before it can actually start the container for the larger one, which can be a big deal for microservices. Like a quarter of a second is a really, really long time. So this was, you know, again, super. The size of the image is also like has an impact on the performance.
Yeah, and this is what have we learned. So you will see immediately based on this result. So you need to really consider what you want to really measure. And we always talking about, in case of microservices, oh, we can easily scale up, but it's not just about starting a container and serving the request, okay? But so it still requires time just to instantiate a new container. So from Kubernetes perspective, and also what we are measuring at this moment from the runtime language perspective as well. So let's see what we have. So first, I just deployed one pod and run the test through a load balancer. The load balancer was traffic, which was maybe a bad decision, you will see soon, but we started with that one. Okay, we got these numbers, which is much worse than we had on the OCI compute instance, but obviously this is an external call. Okay, so it requires some network communication, some load balancing, routing, whatever, stuff like that. Okay, so we have a couple of layers what we need to go through. So what we got here is basically Golang and native image was almost similar, and Java was obviously much slower in this case. Okay, let's see for 100 pods. So I have started 100 pods, but what we got, it was much more interesting. So what we would expected that we have 100 threads in the load. So which means if we have 100 pods, maybe we can somehow really balance between them and we could get a better result, but we got almost the same one or worse, which is pretty interesting. So at this point, I didn't want it to really dive into what is happening in the network, so I decided to move internally to the Kubernetes cluster because I just wanted to really measure what happens on the Kubernetes environment. Okay, so let's eliminate the load balancer, traffic, whatever. So I have created the JMeter Docker container and I have run it on the same Kubernetes cluster using the cluster IP address. So eliminate any other outside networking communication. Okay, this has the results. So we got much better performance in this case. There you can see the Golang was able to have 1.2 response time, second response time, and Go had the far more larger throughput in this case. And this is still one pod, okay? And once we have 100 pods for the same test scenario, the result almost the same, however, for Go, but for native image and Java, you can see some more improvement. Okay, so with scaling, you can have better result, which we need to somehow evaluate, but this is out of scope at this moment. So it is interesting that Golang wasn't faster, even if it had 100 pods at this moment. Okay, what you need to really consider here, even if we achieve this result, that I need to tell you not just the size of the container images, but the size of the memory which is allocated for every container instance. It is higher in case of Java, like compared to native or Golang. So whenever you plan to use Java for microservices, you need to consider the fact, okay, you can achieve the same performance, but it requires a lot of memory, and you are going to pay after memory and CPU usage, usually if you use a cloud provider. So again, so whenever you think about Java versus Go and microservices world and cloud native environment, the most proper way to use the native image options if you want to develop Java applications. So a couple of things what we have learned. Mark, do you want to cover this?
Yeah. So so some things we notice, the Kubernetes scaling is not really that quick. It's a little slow compared to what we want for a true like microservices environment. These are in no particular order. These are just observations. Java, like we said before, Java seems to be much better at using all of the available CPU than Go. In every test, other than the very small machine, we saw that Java always used more of the available resource and got better performance. Go seemed to perform better on the smaller machines, and Java seemed to perform better on the larger machines. Go seemed to be more consistent, which is probably because of the way that the Java garbage collector works compared to Go's garbage collector is much simpler algorithm than Java's. And on a decent production side, like on a server machine, as opposed to a desktop, Java was easily as fast as Go, or in some cases it was faster. Logging seemed to be the biggest bottleneck that we found, and that was true for both Go and Java. And, modern versions of Java, like, Java 11, 12, 13, 14, 15, new frameworks like Helidon that are super lightweight, are really making a big difference in reducing a lot of the pain with Java's, well-known issues like the boilerplate verbosity, the garbage collector performance, the startup time. That a lot of that stuff is getting a lot better. And I think, if you're still working with Java 8, if you were to go and, write an application on Java 14 and run it, for example, you'd notice it's made a huge step forward between, 8 and today. Next one, please. So this is like a what next. I guess this was really interesting, and we really enjoyed doing this, but we want to keep working and doing some more stuff. So we want to do more work with Kubernetes and looking at the horizontal pod order scaling capability. We think that our microservice might be too simple to really, when we tried this, we got the results were all the same, there was no difference. So we think we might need to use a more complex business logic in the microservice to be able to actually see, or maybe we just need more load so that we can see some differences. So we're going to do some more work on that. And also we might want to look at starting to look at things where we have multiple microservices that are interacting with each other. And things like the circuit breaker pattern that's commonly used in microservices, and network tuning and balancing to see how that impacts the performance and how we can use that to tune the performance of a network of microservices. The logging issue we mentioned was a big deal, so we want to look at what are some of the options there, for example, using the pod logs, having Kubernetes collect the pod logs so that we don't have to do it ourselves, or using putting the logs out onto a streaming service or something, or a thread or a topic or something like that. We also were going to look at the actual object code and compare the actual instructions that are being executed on the machines to see if we can do any optimization in the code paths to make sure that they're really as similar as they can be. We did wonder early on if JMeter was maybe not fast enough, not able to generate enough load without actually consuming all of the resources on the machine and becoming a bottleneck itself. But as we tested with JMeter on the same machine, different machines, that sort of thing, it was clear that was not a factor, that it was not impacting the results at all. So, and it could easily create enough load for both Go and Java implementations, even on the 72 core machine, 36 core machine. The other thing we want to look at is like Peter mentioned, in microservices and in cloud in particular, things you're paying for the CPU and the memory. So we want to do a lot more measurements around startup time for containers, the memory footprint, and the CPU usage and that sort of stuff. And maybe even align that with the prices for memory and CPU to see what the differences are there. So we're planning to do some more work and experiments and get some more results, and we'll publish that data out in blog posts. So if anyone is interested to see, what happens next as we go further, then we can give details where you can learn about that.
Yeah. So we clearly, So we clearly don't want to, and we can't say, winner. Who is the winner? It depends on the context, the characteristic of the application. Microservices is a really trending topic, but not everybody is, Netflix or Twitter or stuff like that, where you need to run hundred thousands of instances and where you need to care about really the memory and startup time, stuff like that. So it depends on, and also in this case, you need to consider the developer skills at your company and stuff like that. So it's just, a measurement. And also now we have this option to use the native image that makes much more comparable to Go, which is a new and pretty fast and pretty good runtime environment. Okay, so this is this presentation about just another comparison. Okay, one word about Helidon. So why we have used Helidon. This is our open source project, and this is a microservices framework. So as Mark told, it's much more easier to write a microservices application if you have a framework. But what is important, it needs to be lightweight, it needs to be really performant, and also if you consider the native image options, it needs to be it needs to support the native image, because not every microservices framework supports the native image compilation. So that can be a problem, but Helidon supports that as well. So if you are interested, just visit helidon.io and find out more about our lightweight microservices framework. Okay, this is what we have so far. If you have any question, please post on the Q&A.
Hey, Peter, Mark, there are a couple of questions here from the audience. Hay un par de preguntas aquí de la audiencia. I will read them first in Spanish and then translate them for you. Dice Luis Manso que si han realizado pruebas de performance en aplicaciones de microservicios desarrolladas en Go en comparación con aplicaciones desarrolladas en Java. Me gustaría saber si hay mejoras en escalabilidad y utilización de los recursos. So Luis Manso is asking Peter, Mark, that if you have performance tests on microservices applications developed in Go compared to applications developed in Java. And he would like to know if there are improvements in scalability and resource utilization. So that's the first question.
Sorry, would you repeat? Maybe I didn't understand correctly.
Yeah, the question is, or he's asking if you have performed performance tests on microservices applications developed in Go compared to applications developed in Java. And he would like to know if there are improvements in scalability and resource utilization.
Yeah, the scalability was pretty similar. Java used a lot more resources than Go. That would be the big takeaway, I think. But when we used the native image compilation for Java, it used less resources. It got closer to Go, but Go clearly used a lot less resources. But on the flip side, in the tests on the larger hardware, Go used less resources, but it was also a little bit slower than Java, which was interesting.
Yeah, so clearly, if you see the resource requirement, the Golang and the native image is the option, and also if you need to consider the startup time, then the native image is your tool. But again, so we are looking for the answer because there are still a lot of Java developers out there. And okay, so you can start to use Go immediately, but as Mark also mentioned, that it doesn't have such amount of tools to develop an application like what you have for Java. So in Java nowadays, it's pretty easy to develop any application, okay? And for a company, it's easy to get a Java developer at this moment, okay? And also cheap, so we can say.
All right. The second question, la segunda pregunta es, ¿existirá mejoras si el log se usara como eventos topic? And the second question is, if in your current scenario, the one that you show us, if would there be any improvement if the log was used as topic events? That's what the audience is asking.
Yeah, that would be typically the what? Sorry.
Yeah, no, go. You go ahead.
Yeah, so this would be typically the what's next part. Okay, so this was a really simple, test. But when we are considering a real microservices application, so we store somewhere else the logs and stuff like that, it involves other resources what we are starting to measure. Okay, so the first round was about really about the Java and the Go comparison. Okay, but just follow our blog posts, and we are going to include in the future more and more microservices application stuff.
Okay. So I think we are at the end of this session. Thank you, Mark. Thank you, Peter. Gracias a Mark y gracias a Peter por su participación. We really appreciate your help. This is Groundbreakers Tour Latin America 2020. Y recuerden que existen los servicios gratuitos de Oracle. Ahí está el QR code por si lo quieren escanear. Síganos en las redes sociales. Estamos como @LAUC en Twitter. Ahí pueden ver todos los posts que hacemos sobre este evento y otros eventos y contenidos, blogs y demás de la comunidad. Y remember that you have the always free tier in Oracle Cloud, so you can try it. There is the QR code. And we are going to continue with our event. Remember that today is the Java track day, and we have just started with Peter and Mark, but we have a very strong agenda for the rest of the day. Tenemos una agenda todavía más grande para el resto del día con el track de Java. Gracias por su atención. Thank you, Mark. Thank you, Peter. Again, we really appreciate your support.
Thanks everybody for coming, and thanks for having us.
All right. Thank you. Bye. Hasta luego.